then you can go through the recorded version. So some recording of last week should be made available to you. You compile by taking the things from her also and give it to me. So all those who were absent last week should view it at leisure time for them. I am sure that you must have got the DVDs of the lecture from your seniors. Yes or no? Somebody has got, right? Circuit Theory by Siddhartha Roy. Have you got it? Yes or no? Why you could not get it? Why you did not approach your seniors? Did you approach anybody and these were not given? You were supposed to view 20 lectures by today. And we were supposed to conduct the test, which you have not done. Before tomorrow when we meet for the lecture, everybody must show me the DVDs containing the lectures. Or on the laptop, those must be available for you in the hard disk. Circuit Theory by Siddhartha Roy, IIT Delhi, it is available on NPTEL. From that you can download, but it may take some time. So all the files are available with your seniors. You get them and start viewing them. So 20 you should finish by this weekend, 20 by next weekend, and 10 by remaining weekend. So in 3 weeks you are supposed to finish all those viewings. Then, considering the discussion last week, which was on water level model and all these things as a primer, we can say that effectively we are beginning from today. Most importantly, you are supposed to keep it in mind the few simple things, and which I will list here. First of all, it is presumed now that voltage we are aware of, even though not completely, we are having partially aware of. Current we are aware of, charge we are aware of, or we feel that we have understood these things. I would not like to disturb those feelings at this juncture. We shall continue with those feelings. We shall develop ourselves, and slowly, when I feel that a time has arisen for appropriate understanding, we shall try to revisit whether our feelings about these variables are correct or these need to be further changed. So, our all things are most concentrated with V, I, R, L and C. V, I, R, L and C, and Q one need not write separately because in I it comes flow of charges, the current, right? So these 5 we stress more. This is required, but it indirectly comes here itself. It also indirectly comes in this way also. Is it clear now? Then the relationships for resist. All these are two-terminal devices. All these are two-terminal devices, right? Each is having 2 terminals. Its constructional details we are not going to discuss right now. For that I will give an example. In the first year, you had come from various places. After coming from various places, you started interacting. And in that process, when making new friends, this is a process. In that process, whether do you ask another person about the reports of his composition of various types of, say, what is adrenaline percentage, what is hemoglobin percentage and all that? We did not. Even though it is possible by advanced technology today that for every individual, what kind of person he is, his structural composition can be printed on a paper, right? That is structural composition. So resistor means it is made up of carbon film or a very thin conductor, like that. Similarly, an inductor, it is with winding of copper on ferrite rod, something like that. Then capacitor, we are having 2 plates, metal plates, Then there is dielectric. The dielectric is having some dielectric constant and all that. How exactly then there may be to further confuse electrolytic capacitor and all that. So you did not demand from the newcomer his report, medical report to interact and to befriend. But what happens? Accidentally you maybe when you come, you may ask some question. Where is that student section and like that. So through such incidental conversations, what you come to know? You come to know what is the response of the person in front of you, and based on that you form the opinion. Is it correct? I think it is the process with which all normal people go. So I am not going for structural study of an individual, but I am doing behavioral study. Is it clear now? Structural, even though behavioral study is dependent on structural study, and knowing structural study I can find what is behavioral study. And structural study being very complex, I avoid that, and simply on behavioral analysis I can form my opinion. Similarly, I will not be, if we decide to go into each and every structural detail, in that case we may be so confused to such an extent that we will not be able to progress at all. Because even if we take away resistor, then how current flows, what is the conductor material, what is the atomic composition, what is the free electrons, how heating takes place, why at all conductivity reduces when temperature increases, and all that. How that effect is, if actually a simple question, voltage is called an electromotive force, right? And when we apply some potential across a conductor, it takes away. I give you a simple example just to indicate you that how complex and confusing it can be, but not to confuse you. I am making it clear at the instant beginning itself. The example which I am giving right now is purposefully given just to make you aware that if we decide to think minutely at every point of time, then it would be an endless thinking. Therefore, it is required for us to decide what to assume and what to analyze. Say voltage, if there is a conductor rod, a metallic rod is there, and suppose if it's a battery, then again the question will come, what these two are? It's again metals only. So is it resistor? Yes or no? Let us say that we have superconductors. Even though we don't have, we say we have superconductors. So this is superconductor and this is the, what we can say, the resistor material, metallic material. So it's battery, say 10 volt battery. These are superconductors. We don't question right now. Otherwise the questioning will start now itself. Let's not question. And this is metallic rod. So voltage is called as electromotive force. Have you heard of this name? Electromotive force. So the positive terminal will, what it will do? It will pull the electrons, right? It will pull the electrons. And what this will do? Negative terminal, it will force the electrons away. It will push the electrons. So this is pushing the electrons, this is pulling the electrons, right? Then voltage is electromotive force. So when force is applied, what should happen to electrons? They should move, but steadily. I am forcing. So force should lead to acceleration. Then whether electrons do accelerate? We say constant current flows. Constant current flows means electron flow with constant speed. Why so? Are you getting me? This is a very simple example I am giving, that actually what happens, that can you may, those who want to think and feel that by this thinking they will not get disturbed, can take this agenda for their self thinking. Why in a small metallic cylinder, if a voltage applied from two ends, what makes electrons to maintain a constant flow? Speed of electron doesn't change. Electrons don't accelerate. Why? Electrons move with a constant speed. And since electrons move with a constant speed, if we take any cross section, the number of electrons passing per unit time, or the charge flowing per unit time, is constant. So it is a constant current. Voltage applied V, it is having some resistance R, and V by R is the current. Right? So at this stage, we assume some what we can say statements. Based on those assumed statements, we derive further statements. Right? And once we reach to a sufficient stage, then we may rework on our assumptions. We may rework on our beliefs. It will be the procedure. So voltage, I know something. Charge, I know something. Current, I know something. These three are the different. Voltage and current, these are entities, variables we can say, entities. These are components, right? And for each component, there is a specific relationship between these entities. V and I, these two are the entities. And for each component, there is a specific relation in these entities. Again, the connecting wires we presume to be superconductors. Means, even though current flows through them, there is no voltage across them. That is the zero resistance notion. So, what we try to do now, we try to start from normal things. After starting from normal things, if for a normal fellow will not find any abnormality in normal things, we will proceed. But there may be some Ramanujan. So in a class, it is the centenary year of Ramanujan, death centenary. So when Ramanujan was there in the class, the teacher was teaching a simple thing. If you divide one number by the same number, you get answer as 1. 3, he was just saying 3 upon 3 is 1. 5 upon 5 is 1. 1 upon 1 is 1. And all fellows except Ramanujan were listening to them. Whether they were understanding or not can be a subject of further study. But Ramanujan immediately stood up and asked, what about 0 upon 0? So it is said that he was thinking differently. It's an abnormality. A normal person didn't find it, Ramanujan found it. Because he was exceptional. Likewise, if there are some mini or micro or nano or what we can say kilo or mega Ramanujans within you, then what they may do, they will note down the things in the notebook, and at the end of the lecture, or we may have some special lecture for such Ramanujans in which non-Ramanujans can also attend. Otherwise what will happen? That otherwise the flow changes. There is no bar for any discussion in between by interrupting the lecture, but let normal things finish up normally first. You note down that it is called as interrupt driven system. And in the normal flow, usually I believe interrupt should be masked, and we shall note down. You are noted down what difficulty you have found or what exceptional thing you have found, and which we can interact at a later stage. Means in week we may allot some time for such abnormalities in which we can have a free discussion. Is it all right now? So voltage, current, resistor, inductor and capacitor, Then A and B, A and B, A and B, we do the terminal names. So VA minus VB, VA minus voltage across the resistor is potential at one terminal minus potential at other terminal. How that potential arrived at there right now, we did not discuss. We did not discuss. So VA minus VB is VAB, that we call as VR, right? And current flowing through resistor as IR. Similarly, VL and IL and VC and IC. Is clear now? Then means current flowing through capacitor. Actually, whether it flows through capacitor or we feel that it is flowing through capacitor, we had discussed it sometime last in the, I think I do not remember in this class or the other class. Okay, anyway. So these are three components which are having symbols R, L and C. These are two entities V and I. Q right now is not required. And these are the voltages across the components. Potential of one minus potential of other point. Voltage across the component and current through the component. Current through the component. What is the relationship between voltage and current for every component? The relationship is like this. For resistor, VR and IR are proportional to each other directly. And we have a governing equation. VR is equal to R into IR. Whether this R is the resistance. R is resistance. R is resistance is the component name and R is the component value. This is resistor. Resistor, inductor and capacitor are names of the component, and resistor, a given resistor has got a resistance as R, which can be any real variable, which 10,000. For that, to express, we may give kilo ohms and all that, and unit is in ohms. Unit is in ohms, right? So the relationship is V is equal to R into IR, where R is the value of the resistor or R is resistance of the resistor. Then we go for capacitor. Inductor, we usually not go to that extent. We will go only when it is needed. Even though both are very similar, we get capacitors very easily available in practice. Then for capacitor, the relationship is not direct like this. The relationship is not direct like this. For capacitor, the relationship is between voltage and charge. For capacitor, the relationship between voltage and charge. Charge and voltage are proportional. So QC, which is charge across the capacitor, is equal to C into Vc. QC is equal to C into Vc. If we differentiate it now, then Q by T or dQ by dt is I. Therefore, the relationship is IC is equal to C dVc by dt. IC is equal to C dVc by dt. Current through the capacitor is proportional to the time derivative of voltage across the capacitor. Right? And for inductor, the relationship is reverse. Means, what is the relationship? Can we tell? VL is equal to L Is it clear? So voltage, current resistor, inductor, capacitor. All these things we have covered. Then there is a voltage source. There is a voltage source for which we give a symbol. So what this voltage source does, this voltage source somehow keeps Vs, we can say, source voltage. So voltage, one just subscript you are given, because if we give only V, then V being a general term for voltage, it may not specify a thing specifically. So here. So what is voltage source? Voltage source is actually not a component. Is that not? Is that to that extent not a component, but actually it is what we can say, something active and passive we have not yet come across. So voltage source is something more than a component. I say voltage source is something more than a component. So voltage source is something more than a component which somehow keeps voltage across its terminals as constant. VAB is Vs. So there may be 2 volt voltage source, 3 volt voltage source. Somehow, means we are not interested in how the electrochemical cell is there, or how we can get a transformer and convert it into a source. Right now we are not going to those details. So a voltage source is that entity which is somewhat more than a component, which ensures that potential difference across its terminals is somehow maintained to be constant and is the value of the source. And similarly there is a current source. The symbol of current source is like this. Voltage source is having plus and minus, means why plus and minus? So VA minus VB is, if it is 3, then VA minus VB is 3. VB minus VA is minus 3. And current source, we show the direction of the current source. What current source does? A current source ensures that somehow the current flowing from the path shown is maintained to be a specific value of I, means somehow it will draw the current of, so if it is equal to 2, it will draw 2 amperes from this and it will force 2 amperes on this side. What would be its impact? Right now we need not discuss. In learning process, see, the things which we learn do not happen sequentially. The things are similarly, the things do not happen because you are learning them. The world is existing as of now. At this point of time, many things are there and I am trying to learn them. So if I decide to learn all at a time, I may not learn. Therefore, means if I now learn, I learn that there is a voltage source. It maintains constant voltage across it. Then there may be a Ramanujan who may say, what will happen if I short the voltage source? How voltage would be kept constant? It will need for the infinite current. Or what will happen if I keep the current source open? What voltage will be developed across it? So such exceptional questions we shall. I am deliberately exposing you to exceptional questions because you should develop that test. But right now not answering them. A normal person should not find any abnormal things at the beginning, but it should be made aware that these are also the things which at some or other day we have to come across. So we should not rule out abnormality, but in the initial stage, we are not afraid because of those abnormalities. All things need not be answered simultaneously. So this is the first and foremost principle of learning which we are keeping with us, right? With this now, so voltage source, current source, resistor, inductor, capacitor, and voltage and current. With this we can work on any circuits. Ohm's law we are aware of. Then obviously Kirchhoff's laws are quite obvious. They need not be specifically stated because Kirchhoff's law is something which is natural. Natural in the sense, suppose if one is introduced to a circuit without knowing Kirchhoff's laws, still when I say Kirchhoff's laws are natural, it is not to undermine the work of Kirchhoff. But even if a student is not exposed to Kirchhoff's laws and given a circuit to analyze, he may on his own develop these laws. Therefore, most of you might have gone through these laws, or you might have found them on your own, but these are quite natural, so they need not require any specific definition and all that. So we start with this background now. We start working with the circuits. The way of teaching learning process is now evolving, and means sometimes what happens earlier in drawings, more stress was on symmetry, order, neat color and all that. But when freehand drawing branch progressed, a random thing that may be a good draw. Likewise, in learning whether definition should be told first, then how to deal with the circuit and all that, whether that should be first, means what should be first. The classical thinkers were thinking that no, the student should be neatly explained of all the things. But the students in front of such classical thinkers were different. So there is a generation change leading to a paradigm shift, whereby such classical thing may not be necessary. Let us actually, this time we did not get time. Otherwise, next time what we should be done is my thing, that when we are having the winter vacation, in the winter vacation the students should be made aware of the syllabus and the textbooks. In the winter they will study, and at the beginning of the first semester an examination be conducted on these studies, on self studies, and based on the examination to be conducted, the question should be such that by knowing the answers, not marks are not important, but which questions are not answered, which questions are neatly answered, give the teachers the abilities of the students to learn the things, and it gives an indication which part should be stressed more, which part should be stressed less. There is no point, since very earlier teachers were, when they were preparing the syllabi, taking the book, if the book is of 200 pages and it is of 50 hours are the syllab, 50 hours are stipulated, then in 1 hour 4 pages are to be spent, 4 pages are to be covered. That is a very mechanical distribution. But that one did not give. One would give more stress for the things where stress is needed to be given, and one may declare some chapters if these are too simple. So with the advanced ways of learning now, we start with examples. And we may take a simple example. usually current is in small values, therefore unit is milliamperes, and resistor is in somewhat large value, so unit is kiloohms. But that is not, if initially if you find it odd, I will not take it. I will take it directly, say 20. So we have to find out how much current will flow to this. We can give the points name A, B, and it is a common point C because all are as good as superconductor. Now how do we progress? There are two Kirchhoff's laws. First is algebraic sum of all the currents at a particular node or a point or a junction is 0, and Kirchhoff's second law, that voltage across the loop is 0. These are classical definitions. Conventional or workable definitions: sum of currents coming into a point is equal to sum of current, or currents flowing in is equal to currents flowing out at a node, and battery voltage is equal to voltage drop across a loop. Is it clear? Battery voltage is equal to voltage drop, and currents coming in equal to currents going out. So we may take some, this current is to be found out. So how will you proceed? We give this current, let this current be now I1 we get. This is, or I give this as I1. This is I1 is to be found out. I1 is to be found out. So I will give this name to be I2. And while giving the currents, we give some directions and the values, variable values. If the variable comes out to be negative, it means that the direction is reverse. So this is I2, this is I1. So what? Then at Kirchhoff's law applied at node A, there is no need to write down the law now. It is so, that's why what I say, it's so natural. What will the current in this way now? I2 is coming in, I1 is going out. So I2 must be equal to what?
I1 plus
This is I1, 1. And this should be something, so that this plus this should be equal to this. Means this must be I2 minus I1. Is it clear? This must be I2 minus I1. Is it okay? Alright, no problem. Then, can I proceed with this information only? I think probably not. There is no classical way of solving the problem. If classical way is to be taught, then it will not be learned. I do not believe in classical way, because one can teach in a classical way, but students do not learn. So unless the students learn, there is no point in adopting that way. So here I feel that something, just there is no classical reasoning, but I am feeling that something on this side is incomplete. So I need to complete. So what I will do, this current, and now I feel that it's a feeling, not supported by any kind of rule as such. Since it's positive terminal, it will be like this. So if I say this to be I3, what this must be now? I1 plus I3. So is it clear now? So I have got I2, I1, I3. I have got three variables. So now I can no more apply Kirchhoff's node law, because I applied that. Kirchhoff's current law or Kirchhoff's node law I have applied. By applying that, I try to reduce the, otherwise what will happen? For every branch there will be one current, other current, one current. So there are 5 different branches in which currents will be different, right? Maybe I1 or I1, I2, I3, I4 and I5. I1, I2, I3, I4 and I5. Of that, by applying Kirchhoff's node law, I reduced 2 variables already. So now node law is no longer useful. Now node law is no longer useful. What is useful now is mesh law, second law. So I can apply it. I do not see any problem with there. We can take some independent loops. So now, this being the first example, I am dealing it with step by step. Then I will give more examples for you as a homework, teamwork, classwork and so on. So, what equation I write? I have to take one loop. When I take one loop, I did not look outside the loop. So, first loop I will take naturally, means a conventional person thinks in this way and not in this way. I do not know how left-handers think, but I think by visual approach, I think in this way only. So I take the first loop immediately. So if I look at the first loop, I need not look outside. So what is the voltage source? First loop, 2 volts. That must be equal to voltage drop. So voltage drop is what? From here, you come, how many resistances are there, and voltage will drop. Means when current flows, voltage will drop. So what is the voltage across this VAC? I2 minus I1 into 10. So 2 is equal to 10 into bracket I2 minus I1. One equation is there. Whether everybody agrees? What I will do, for just simplicity, I remove these zeros so that even though answer may come in amperes, right now it's a material for me. So, is it clear now? 2 is equal to 1 into I2 minus I1. So, first equation is available with me. This is I say the equation 1. Then which I loop I will take? I will take this loop. I take this loop, right? So, what is the case now? Again, 2 is equal to what? From this to this. What is voltage drop? 2 into I1. Where voltage is 2 into I1. Plus, from this to this, what is voltage drop? 3 into I1 plus I3. Then now what? Now what loop I will take? I can take many loops are there now. I can take this loop also. I can take this loop also, and I can immediately find I1 actually. There was actually no need to take these things. Why? What is I1? I1 is equal to minus 0.5. Anyway, somehow accidentally in the problem I had given something for which instant answer is available, but we can find it by systematic way also. What is that now? So here we have come to a conclusion that we unnecessarily are using the various variables. What is the reason being? If I take this big loop, what is VB? 3. What is VA? 2. So what should be I1? Minus 0.5. But anyway, we can find by this way also. What is this now? So 3 volt is equal to 3 into I1 plus I3 is the equation. Right? And then what happens? Now when 3 equations are there, you can solve by many techniques. Maybe by classical techniques or maybe by techniques which suit you. You immediately find that you can put this equation here. You can put this equation by putting equation 3 into equation 2. We find that 2I1 is equal to minus 1. By putting equation 3 into equation 2, 2I1 is equal to minus 1 or I1 is equal to 0.5. I1 is equal to 0.5. So accidentally we gave the but still okay, this problem we can change here itself. How? What will be this current? Then for that purpose you have to solve, or you need not solve again. This current will be again same 2 volts 1, so this must be 2. So this current is 0.5 like this. This current is 2, and what about this? This current is 3. What is this? Is it wrong, right or no? What is this current? 2 volts, 2 amperes, 3 amperes. That's correct. No problem. So this is 3.5 from this battery, and what this is 1.5. Anyway, we take a simple accidentally we took very simple example. We take one more. Find voltage across the resistor of 3 ohms. How will you find this now? How will you proceed? This is presumed to be 0 with respect to that we are counting. Therefore, we may say rather than VD being 0, we may say this is VA, this is VB, this is VC, no problem. And VB just ignore it. We presume this to be 0. Instead of V being 0, this is VA, VB, VC. So how can we proceed now? How will you get the answer? Those who joined late should, I will again call them. Number 5.
Yes, sir.
Number 12.
Yes, sir.
Number 22. Is not there, na? It's blank number. Number 34.
Yes.
Number 38. What about 38? Number 54.
Yes, sir.
Number 60.
Yes, sir.
So only 38 is the absent fellow today. So anybody got the answer? What is it? Okay. Let us not ask the answer. We shall solve it being the first class. So what do we do? Node law is to apply it first because it is very simple to apply. I give you simple rules. Apply node law first, which is very simple to apply. So what is it is? Let this current be I1. Let the I2 go here and I1 minus I2 come here. Is it right? You are free to choose the way in which you want to assign the variables. So now 5 volt is equal to Kirchhoff's mesh law applied for this. So 5 volt is the voltage source, battery voltage, and voltage drop. What this would be? Oh sorry, I have not given 2. So it is, what is the drop across this? 2 into I1, right? So it will be 2 I1 plus 3 into I1 minus I2, right? 3 into I1 minus I2. And second law, second loop which you can take this. So 10 is equal to what? 10 is equal to, now the loop is like this. So drop would be minus 5i2. You agreed? Because we are, when I am looping, I am looking from this. What is the current in this direction or drop? Minus I2, correct? So it is minus 5 I2 plus plus, now this is same 3 into I1 minus I2. So now you can very easily get into this equation. How can you get into this equation now? Straight away expand it. So 5 is equal to 5i1 plus 3i1 minus 3i2, and this 10 is equal to what? 3i1, and this is minus 5i. Is it correct now? Is it alright? Then multiplying this by 5 and multiplying this by 3, we can solve. I will solve it completely. Multiplying this by 5, 50 is equal to 15i1 minus 40i2, and 15 is equal to 15i1 minus 9i2. So just by changing sign for this, what I get? 35 is equal to something. If there is some calculation mistake, you can correct it later. 35 is equal to 31 I2. You can find I2. From I2 you can find I1, and then you can find voltage V1. Is it clear now? So we will continue that in tomorrow's scheduled time, and then in the additional times given.